Bismillahirrahmanirrahim. In this lecture, we are going to speak about the Cauchy-Euler equations. The Cauchy-Euler equations is a linear differential equation of the form a sub n x to power n multiplied by the nth derivative of y plus a n minus 1 x to power n minus 1 multiplied by the nth minus 1 derivative and so on. What is special about the Cauchy-Euler equation is that the power of the variable x is matching the order of the derivative. X to power n minus 1, the nth minus 1 derivative, or the nth minus 1 derivative of y, up to x to power 1 multiplied by the first derivative of y plus a sub 0 y. So this is the special feature for the Cauchy-Euler equations. The power of the variable x is matching the order of the derivative. So this equation is known as the Cauchy-Euler equation. To find the solution for this type of equations, we will substitute y equal to x to power m, as we did for the undetermined coefficient or for the auxiliary equation of linear differential equation with constant coefficient. We replaced y by e to power mx. But for this type of function, we replace y or substitute y by x to power m. And if we differentiate this function, y equal to x to power m, case time, I will have a x or a sub k, x to power k, then m multiplied by m minus 1 multiplied by m minus 2 up to m minus k plus 1 multiplied by x to power m minus k. Combine this one with the x given to power k, we will have a sub k m times m minus 1 times m minus 2 up to m minus k plus 1 multiplied by x to power m. For example, if we take the second order differential equation, I will differentiate the function y equal to xm 2 times y prime will be m multiplied by x to power m minus 1, and second derivative y double prime equal to m times m minus 1 multiplied by x to power m minus 2. And plug it in the equation, we will have auxiliary equation for that one will be a times m multiplied by m minus 1 plus bm plus c all multiplied by x to power m equal to 0. So I will have a second order or a quadratic equation m to power 2. And for the quadratic equation, as we stated before, we are going to have 3 cases. Either we will have 2 distinct real roots or complex or repeated solutions. We take the first case. If the roots are distinct or real, I have 2 different roots for the quadratic equation. Then we need to find the general solution that will be given as y equal c1 x to power m 1 plus c2 x to power m 2. This will be the general solution for the distinct real solutions. For example, if we have this equation x squared y double prime or second derivative of y minus 2y equal to 0. To try to find the solution for this equation. As we said, y is equal to x to power m. This will give me the first derivative is equal to m, x to power m minus 1, and the second derivative is equal to m multiplied by m minus 1 times x to power m minus 2. Now replace second derivative by this one, or substitute and y by x to power m in the equation. I will have x squared multiplied by second derivative is given by m times m minus 1 times x to power m minus 2 minus 2y, which is x to power m, equal to 0. So I will have, if we combine this one with x to power 2, it will be x to power m. So it is m multiplied by m minus 1 x to power m minus 2 x to power m equal to 0. Take xm as a common factor, we'll have m multiplied by m minus 1 minus 2 or x to power m. So the auxiliary equation is what is inside the bracket, which is equal to 0. I can open the bracket, I will have m squared minus m minus 2 equal to 0. Find the roots of this quadratic equation. By factoring it, it will be m minus 2 multiplied by m plus 1 equal to 0. This will give me two distinct real roots, that m1 equal to 2 and m2 equal to minus 1. So the solution for the given differential equation will be y equal to c1 x to power 2 plus c2 x to power minus 1. So this is the general solution for the given differential equation. Solve another example. For that we have xy double prime minus 3y prime. As we did, y is replaced by x to power m. This will give me y prime equal to m, x to power m minus 1, and this also will give me y double prime, which is equal to m times m minus 1 x to power m minus 2. So I will have x multiplied by y double prime or m double prime, it will be m times m minus 1 x to power m minus 2 minus 3 y double prime, that will be m times x to power m minus 1 equal to 0. Can take, okay, just combine this x with x m minus 2. I will have m multiplied by m minus 1 multiplied by x to power m minus 1 minus 3 m x to power equal to 0. We can take x to power m minus 1 as a common factor, then I will have m multiplied by m minus 1 minus 3m multiplied by x to power m minus 1. I will have m squared minus m minus 3m equal to 0, or it is m squared minus 4m equal to 0. So either will give me m equal, or we can take m as a common factor from this one. I will have m minus 4 equal to 0, and this will give me two solutions, m equal to 0 or m equal to 4. So the general solution will be y equal C1, but this is 0. This will be x to power 0 plus C2 x to power 4. Which can be written as C1 plus C2 x to power 4. So this is the general solution for the given differential equation. For the next example, I have x squared y double prime plus 5xy prime plus 3y. So I can replace now directly. I will have x squared. The double or the second derivative of y is given by m multiplied by m minus 1 x to power n minus 1 plus 5x y prime, which is m multiplied by x to power m minus 1 plus 3x to power m equal to 0. This will give me, we just combine these together, I will have x to power m. So I will write it directly as x to power m and take it as a common factor. We will have m multiplied by m minus 1 plus 5 m plus 3 x to power m equal to 0. Then the auxiliary equation will be m squared minus m plus 5 m plus 3 equal to 0, or it is m squared plus 4m, just combine these together, plus 3 is equal to 0. Now this one can be done by factoring, which is that will be m plus 1 and m plus 3 equal to 0. That will give me two solutions. m1 equal to minus 1 and m2 equal to minus 3. So the solution will be y equal to x to power or C1 x to power minus 1 plus C2 x to power minus 3. So this is the idea for finding the solution for the Cauchy-Euler equations. We need to find the solutions of the quadratic equation if we have speak about the second order differential equation. And this is the first case. If the quadratic equation has two different or two distinct real solutions, the general solution will be y equal to c1 x1 or x to power m1 plus c2 x to power m2. Next time, we are going to speak about the second case when the solutions are repeated, or if the two solutions of the auxiliary equation are complex numbers.